Hello, 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 everybody. I hope you are all doing well. And you're ready to finish up Part B on our 2015 open paper. A farmer has a flock of N sheep, where N is between 2,000 and 2,100. The farmer puts some number of sheep into one barn and the rest of the sheep into a second barn. So we might say, B number of sheep into one barn, N minus B sheep into the other barn. The farmer realizes that if she were to select two different sheep at random from her flock, the probability that they are in different barns is exactly 1/2. Determine the value of N. So likely with the setup of this question, there's lots of different values of N that will work, but there's only one in this particular range. So that might break the problem down into two parts. Okay. So what's the probability? So if she were to select two different sheep at random, so let's figure out some probability, shall we? So probability is number of outcomes we want to count over the, oh, that's not a good line, over the number of outcomes that are possible. So in how many ways can two sheep be selected? Okay, well, if you've got N sheep, you've got N choices for the first sheep, and N minus 1 choices for the second sheep. But of course, if I pick, sheep Alice first, and then sheep Betty second, it's the same as if I chose Betty first and Alice second, because we don't care about the order the sheep are picked in. So we actually count every pair of sheep twice here. So we divide by 2. So a number of ways to pick a pair of sheep. It's a neat little formula. I've explained it just very briefly there, but it's a good one to know when it comes to choosing and probability, and you'll learn more about it in more advanced math courses if you continue on with that sort of a thing. But now we've got the number of ways to pick a pair of sheep. Okay. Number of outcomes we want. Well, we want one sheep from one flock and one sheep from another. So, what should we do? Well, there's B ways to choose one sheep from one of the flocks, from one of the barns, and N minus B. So we might say let B equal number of sheep in first barn. I don't know what B is, but I know that B times N minus B equals number of pairs of sheep from different barns. Right, and that's what we were looking for. Farmer realized if she were to select two different sheep at random from her flock, the probability that they are in different barns is exactly 1 out of 2. Okay, so 1/2 should be equal to B times N minus B all over N times N minus 1 over 2, which is going to be 2B N minus B over N times N minus 1. So if we cross multiply, N times N minus 1 is equal to 4B times N minus B. I suppose we could expand this out. And maybe get a quadratic, I guess. Oops, now why would I write 1? 0. There we go. Okay, now I don't think this can be easily factored. That's fine. But we do know there should be a solution, and it should be an integer solution as well. I'm also wondering, no, we should get the same, so I was just thinking for a moment, well, the probability that the sheep come from the same barn would be this, and that probability should also be 1/2, but I suspect we'll get the same quadratic if we do that. Well, it's something to think about. But this would also be true, and I'm wondering if they're just trying to hide the probability there. I don't know. Let's take a look at this quadratic, and if things get difficult, we'll try something else. So n needs to be equal to negative b. And now I probably shouldn't have used b for the barn sheep. Plus or minus the square root of b squared minus 4ac all over 2. Well, 2a, but just 2. Alright, did I got that right? Yes. Okay, so we'll get n is equal to 1 plus 4b plus or minus the square root of, and then what's inside here needs to be a square. Not only that, it's got to be an odd square because we've got an odd number here, and we have to divide by 2, so you have to either add an odd to an odd or subtract an odd from an odd. You can't add an odd to an even and then divide by 2 and get an integer. So what do we have? We'll have 1 plus 16b plus 16b squared minus 16b squared all over 2. So n is going to be equal to 1 plus 4b plus or minus the square root of 1 plus 16b, because those cancel out, all over 2. So 1 plus 16b must be an odd square. Now this doesn't seem that difficult. Surely this should be able to happen. So 1 plus 16b, if we said this was, say, 1 plus 2c squared, we'd get 1 plus 4c plus 4c squared. So 16b would be equal to 4c plus 4c squared, or 4b would be equal to c plus c squared. So, now c plus c squared would be equal to 4b, and b has to be less than or equal to n. And do they say they have to be, put some number of sheep in the rest of the sheep? Could we allow 0 many sheep in one barn? Something to think about. But b is, I'm going to say at least definitely between 0 and n, maybe strictly between them. But we'll see. We get 4n here. Okay. This might limit things, but let's see. What if we said something like c is 1? Right? So then if c is 1, then we get c plus c squared has to be equal to 4b, but that means 2 is equal to 4b, so that doesn't work. We need... So c plus c squared equal to 4b implies c plus c squared is a multiple of 4, because b has to be an integer as well. Alright, let's look at a few c's. Obviously, if c is 0, then c plus c squared works. And then we get the b is 0, and we can deal with the n later. But if c is 1, then we get 2. That's not going to work. What if c is 2? Well, then we get 6. That's not going to work. How about 3? That'd be 12, and so your b would be 3. Well, that's kind of nifty. So then, I'm just going to, so if I did 4, then we'd get 20, and the b would be 5. If we did 5, then we'd get 30, so that wouldn't work. I bet it's going to repeat, and c has to be congruent to 3 or 4. Mod 4. Actually, let's see if that would work. So obviously if c is a multiple of 4, this is going to work out just fine. But what if c is a multiple... Well, what if c is 4k plus r? c plus c squared would be 4k plus r plus 16k squared plus 4kr... No, 8kr actually. plus r squared. And so we need r plus r squared to be a multiple of 4. Only happens r equals 0 or r equals 3. So C is, if we wanted to be fancy, congruent to 0 or 3 mod 4. Anyway, getting back to it, if I had B is equal to... So if C was equal to 3, we're just looking at a small case here. C is equal to 3, B is equal to 3. N is equal to, what was it? It was 1 plus 4B plus or minus the square root of 1 plus 16b all over 2. Now in this case, 1 plus 16b is going to be 49. So we get 1 plus 12 plus or minus square root of 49 all over 2. So we get 13 plus or minus 7 all over 2. Now n has to be greater than b, so n will actually always be the plus option. Right? Well, if you did minus, then n would be... So n is either equal to b. Now, we'll keep the minus sign in. So n is equal to 6 over 2, which is 3, or 10. So if we just have 10 sheep, and we take 3 of them, put them into one barn, 7 of them put into another barn, we should be fine. Does that track? 3 times 7 is the number of ways to get sheep to pair up when they're in different barns, divided by 10 times 9 over 2 is 21 out of 90, which is 7 over 30, which is not equal to 1/2. So what has gone wrong? Something's gone wrong, clearly. Got our n times n minus 1. 4bn, 4b squared, so plus b squared. It's minus 1 plus 4b. This should be working, and yet it isn't. Yeah. N is negative b, and then b squared. Oh, you know what it is? This is an 8. So we need 1 plus 8 squared. Or 8b. There we go. Alright, I knew there was a problem somewhere. Let's see how the rest of this carries through. So putting an 8 here. And an 8 here. We need... So divide by 2, we get 2b is equal to c plus c squared, but that's always true. Because that's c times c plus 1, and that's always true because one of these is odd, one of these is even. So that works out. So b has to be equal to c times c plus 1 over 2. Fair enough. So we don't need any of this, because we don't need to find c values that work. We don't need any of this, because again, don't need anything special about our c values. So let's try something else, and we'll ignore this calculation. And we'll say, okay, what if we let c be 3 again? Well, then b is equal to c times c plus 1 over 2. So that's going to be 3 times 4 over 2. B is going to be 6. A little big, but that's okay. We can deal with that. And then we'll get n is equal to 1 plus 4b. 4 times 6 plus or minus the square root of 1 plus 8 times b all over 2. So this is going to be 25 plus or minus the square root of, once again, it'll be 49. So we'll get 25 plus or minus 7 all over 2. So we will get either 32 over 2, which is 16, or 18 over 2, which is 9. Okay. Sure. So either one should do the trick. What if we have 9? So 6 times 3 out of 9 times 8 over 2. That's 18 out of 36. Hey, that's equal to a half. 6 times 10 out of 16 times 15 over 2. That would be 60 over 120. That's equal to a half. Great. Alright, so I understand how the b's are put together and therefore the n's are put together. Could we do this better? Yes, I think we can, because I know what the b is. It's 1 times 4b, but b is c times c plus 1 all over 2. And the 1 plus 8b is 1 plus 2c squared. So square rooting that should just be 1 plus 2c. And we can actually get rid of the 2 there and just say it's 1 plus 2c over c plus 1. And we can divide by 2, so we can get, let's see, either we subtract and we get c squared, or we add it on and we get c squared plus 2c plus 1, which is c plus 1 squared, and that's actually why we got a 9 and a 16. Great. So n needs to be a square. And it doesn't even matter which square. So, is there a square in between 2000 and 2100? Let's see, I think 45 squared is in there. Because that should be 2025, and then 46 squared. We should add on 45 and then add on 46. So if add on 45, you'll get 2070. If you add on 46, it'll be too high. So 2025 is the only one that works. So that's the only square in that range. And there we go. And we could even double check what would be our C value for this one. Well, we could take C as 45 or C as 44. Either one would do the trick. And then we could get a B from there, but they just want the one value for N. And I'm happy with the way the calculations worked, other than, you know, my mistake here, but that was just my arithmetic mistake, which goes to show you, be careful when you do your arithmetic. But other than that, the question went rather smoothly, so I don't really feel the need to check this. If you wanted to, of course, you can't grab your calculator, but you could say, all right, I'll choose this C value, either 44 or 45, compute a B, and then do the calculation for probability. But as I say, I don't feel the need to do that. So that was B4. Up next, we'll be starting the Part C for our 2015 paper with C1. So give the Part C questions a shot. I really encourage this, and I will see you for C1 in the next video. Take care.